Okay, welcome back, everybody. If you're just joining us, I'm Micah Russell. I'm the director of the Master in Environmental Management program. It is a real pleasure and a privilege to be walking you all through all presentations today, tomorrow, and Friday. This is an opportunity for our students, both in the MEM program and the MS Ecology program, to show off all of their incredible accomplishments on behalf of a wide array of stakeholders and partners. So the cumulative impact that our programs have is really impressive, and we've had fun this morning and looking forward to this afternoon's talks as well. Congratulations to everyone who's finished already, and thank you for being here to support those that are about to present next. So without further ado, I'm going to welcome to the stage Addie, Payten, Savannah, Yetunde, and Brenan. Welcome.
Thank you, Micah. Yeah, as Micah said, well, it's my pleasure to really introduce our panel, Phases of Rewetting the Gunnison Basin. And I'll reintroduce us. My name is Brenan. This is Addie, Savannah, Payten, and Yetunde. And our panel consists of passionate students who are working with 4 different organizations to restore wetland and wet meadow ecosystems in the Gunnison Basin. Collectively, we have planned, implemented, and monitored over 250 acres of wetland and wet meadow restoration projects within the valley. Our projects share the common goal of building local resilience through the restoration of fragile mountain ecosystems in the face of an uncertain climate future. We are excited to discuss the different phases of restorations and the processes and the critical importance of these ecosystems.
So all of our projects are located within the Gunnison Basin, which is a region vital to the health of the Colorado River. It's a major headwaters area and the largest tributary of the Colorado River in terms of water volume. In addition, the basin supports diverse riparian wetland and wet meadow habitat that are really important for a plethora of plant and animal species, including the endangered or the threatened Gunnison sage-grouse. Gunnison County is unique because it comprises of over 80% public lands. And this doesn't even account for the state and private lands that are dedicated to sustainable management. This paired with the dedicated and innovative land managers and community make the Gunnison Valley an incredibly unique setting for collaborative management. As you'll see later in the panel, all of our projects were connected in some way, and this element really makes this work successful. We also wanted to acknowledge the Indigenous people who have stewarded the land since time immemorial, especially the Mountain Ute.
Wetland and wet meadow ecosystems are crucial because they provide a range of ecological services, including regulating water quality, supporting diverse plant and animal communities, reducing the impact of floods, and sequestering carbon. Wetland and wet meadows also help to maintain water availability for human consumption and agricultural use, support recreation activities, and offer cultural and spiritual values. Additionally, they provide habitat for threatened and endangered species, migratory birds, and other wildlife. These ecosystems are under threat due to anthropogenic change, such as urbanization, land use activities, and climate change, making their preservation and restoration critical for maintaining biodiversity and ecological resilience. Many of us were introduced to the realm of wetland restoration, especially low-tech restoration, through the extensive community engagement opportunities within the valley.
So a lot of us came to Gunnison familiar with traditional riparian restoration techniques that are highly expensive and incredibly engineered. A low-tech process-based restoration is mostly used here in Gunnison for smaller rivers and riparian areas as a cost-effective technique. They tend to utilize native materials like rocks and sticks to slow down the water passing through, drop out sediment, and to restore the historical hydrology. These techniques have the building principles of maintaining and expanding natural moisture storing areas, preserving and cultivating regenerative plant communities to rebuild and maintain soil, creating site-specific solutions utilizing natural features and processes, as well as my favorite, to strive for beauty and inspiration. These structures tend to work with each other, and there can be over 100 structures within one site. But they also are very low profile, and you can drive past these sites, and if you don't know what you're looking for, you probably won't see them. What structures you put in is entirely site dependent. Perennial wet systems tend to use more BDAs, beaver dam analogs, while drier ephemeral systems tend to utilize more rock structures. And like I said, it is completely site dependent on what structures you implement.
Restoration activities began on wet meadows in the Gunnison Basin in the year 2012, and this was done to enhance the resilience of degraded ecosystems. Afterwards, restoration managers came up with certain objectives, and one of these objectives was to engage in a continual monitoring of restored ecosystems. This was to ascertain if the restoration activities that were carried out were quite successful or not. And over time, the vegetation monitoring that researchers have engaged in have showed that there have been an increase in vegetation productivity. And currently, stakeholders, students, and many others are engaged in other monitoring activities, such as soil moisture monitoring, water quality monitoring, among others.
Together, our projects highlight the different processes and phases of restoration, from community engagement, project planning, implementation, and monitoring. Together, we showcase the amazing work being done to re-wet the Gunnison Basin. And now Addie will present her project.
Everyone. My name's Addie Mandeville, and my project focused on enhancing the stewardship program of High Country Conservation Advocates, or HICA, through community engagement. For the past year, I've worked as their Environmental Stewardship Fellow. So a little bit about HICA. HICA was founded in 1977 when the residents of the town of Crested Butte fought a mine on Mount Emmons, or Red Lady, as you can see on the slide. It's a nonprofit deeply rooted in the public lands of Gunnison County. It was actually the longest mining battle in the West, 45 years, and it was really exciting to work with them this year, as the mining company announced the withdrawal of mineral rights and land exchange that intends to permanently end mining threats on Red Lady. Throughout the years, HICA has also developed other programs, including public lands, water, and stewardship, which I focused on. The stewardship program was created in 2018, but it really didn't develop any partnerships until 2020. And in 2021, they hired their first MEM stewardship fellow, Eli Smith, who really got the program on the ground and running. He made new partnerships, got funding, and developed more of the program. He was hired as the first stewardship director after his fellowship, and I was hired as a second environmental stewardship fellow to support the success of the program. Environmental stewardship is important because not only because of the on the ground restoration and conservation work, but it also creates an awareness in the local community of our impacts on the environment. Many Western towns are facing environmental issues due to climate change and drought, recreational tourism increase, and population increase. And while these are really large problems to solve, stewardship creates an easy pathway for people to make a difference on the landscape and become more aware of their local public lands. For this reason, I focused on expanding HICA's community engagement. So my project really had two aspects. The first was supporting fieldwork, volunteer days, and the second was increasing community engagement and the stewardship program outreach. So at the beginning of my fellowship, I really, to become acquainted with the organization, I did a lot of tabling, the Gunnison and Crested Butte farmers markets, as well as local community events such as Alpenglow and Crested Butte, or the Gunnison River Festival. Throughout my fellowship, I created pamphlets, flyers, information packets for volunteers and the general public to spread more information about our work. You can kind of see two examples at the bottom of that slide. That's like half of the pamphlet. I also contacted different individuals and organizations throughout Gunnison County to recruit volunteers, find sponsors, and potential projects. All of these contacts and correspondence were synthesized in a shared Google Drive for the HICA stewardship program. So my work could be continued and more of the outreach could become streamlined. Within the drive, I also provided resources, a timeline of when to contact certain groups, sponsors, and individuals in conjunction with the field season and time of year. And I'll briefly touch on some of those connections that I made later in my presentation. I also developed an interactive map for the HICA website, which kind of showcases our projects. Can pull that up. I originally was going to do this through ArcGIS and through what I've learned in my GIS course in the MEM program. However, due to some complications, I had to pivot and use a platform called Mapbox. And halfway through, little did I know that I had to code. So I spent a lot of hours frustrated on my computer learning how to code. And I wanted to thank my uncle, Joey McDonald, for basically teaching me how to do that and getting the, the map on the website. So, this is the map I developed. And it's just a great way to kind of showcase how expansive our projects are all over Gunnison County. We have our upcoming projects here, as well as the work that we've done and little blurbs about them. So just think it's a great way to see it visually. Thanks. Now to the fun part, I'll highlight a few key projects I worked on within the stewardship program. HICA is has a lot more projects than what I'll talk about, and you can view those on the map I made. So the first project we had of the field season was the Willow Creek fence construction. We partnered with the U.S. Forest Service to build a buck and rail fence to protect critical riparian habitat. And right before that, I had made a connection with Gunnison Valley Mentors, which is a really amazing nonprofit that finds mentors for local youth and gets them to do enriching activities around the community. So they're also looking for mentors all the time. So if you live here and are interested, you should look into it. We had 5 middle school girls join us that day to learn about their local public lands from the U.S. Forest Service. Many of them had grown up in Gunnison and never been to Taylor Park, so it was really great to take them out there. And Gunnison Valley Mentors will actually continue to partner with us during this field season and get more local youth out on some projects, so I'm excited about that. Next, we had a great wet meadow restoration Labor Day weekend. So we spent 3 days of doing wet meadow restoration, protecting critical sage-grouse habitat and Gunnison sage-grouse. And I won't go too into detail about wet meadow restoration just because this will be discussed later on the panel. But wetlands restoration volunteers joined us on that weekend too, and we accomplished a lot. There's a lot of partners involved as well. And I also met an employee of the Colorado State Forest Service, and he expressed a need in having some volunteers come out for some of their projects. So we ended up collaborating on an upcoming project that I'll discuss later. So my personal favorite project of the field season was Trail Creek wetland restoration, which many people in this room were involved with too. It's beaver-based, low-tech process-based restoration work. And it's just instantly gratifying because you can really see the water slow down and spread out as you're working on the landscape. It's really innovative. It's received national attention and will be continued each year for the foreseeable future. You can really see the collaboration among Gunnison County with all the different partners involved. And as I discussed before, the collaboration with the Colorado State Forest Service, he expressed a need in having volunteers on protecting Douglas firs from devastating Douglas fir bark beetles. And after some planning, we implemented 2 volunteer days this month. And I wouldn't be true to my fellowship if I didn't make a pitch for everyone to come out and volunteer with us. If you're around, volunteers will assist the staff in hanging pheromone packets on mature Douglas fir trees to mitigate Douglas fir bark beetles from attacking them. So it will protect the trees, and it will also work to keep the forest healthy for devastating wildfires. So if you're around, you should sign up. All of our volunteer days are extremely educational. You get a free lunch. It's super fun. You get to meet a lot of people around the Gunnison Valley community. I wanted to say a big thank you to our partners and sponsors for all the hiccup projects. Just from this slide, you can see how collaborative the Gunnison Valley or Gunnison County is. And those projects wouldn't have been possible without these partners and sponsors. I'd like to say a big thank you to the HICA staff and board, especially Sue Navy, the president of the board, which is basically the essence of HICA. If you want to know anything about the history or their values, you can just ask her. Eli Smith, the stewardship director and my community sponsor, he's just been an amazing person to work with. I was funded by the SMPS Family Fund in Western Colorado University, so my project wouldn't have been possible without them. My mentor, Sally Thone, which gave me great advice and also had a lot of patience with me, which I'm thankful for. And I'd also like to thank the beautiful public lands of Gunnison County for keeping me inspired and sane, and all the great people that work collaboratively to protect and manage the land here. And with that, I'll take questions. Brett.
So 2 questions, you can answer one or both.
Okay.
So with trying to get the community involved, engaged, volunteering, what was a success that surprised you where like you didn't expect it? Or were there any challenges that you didn't expect, and how did you overcome them?
I'll go with, so the question was, with finding community engagement, what was I surprised by in my work, and what was I challenged by? I'll go with the surprise part. I think I'm very introverted, and really the biggest kind of professional development I got with this fellowship was just like blindly reaching out to people. And I really learned that most of the time people are really helpful and they want to become involved, and then they'll give you like a new contact to reach out to. Like, I think I reached out to someone within the county and they gave me a contact for Rotary, and now Rotary is going to come out on some of our projects. Like, it's just, I don't know if it's just, you know, the Gunnison Valley community that's just so collaborative and wants to help each other, but I think that was a big surprise for me. And now I have a lot more confidence when I'm like kind of blindly contacting people about stuff. And that's really helped me throughout. I think it's going to really help me in my career.
Another question.
Addie, thank you so much for all your amazing work across our valley. My question for you is about the map, and it sounded like you had to switch it up. Would you consider that app that you used something that they will continue to use into the future? And how would you compare that to GIS?
Yeah, so the reason that I didn't use GIS is because they didn't renew their ArcGIS license. They kind of like stopped using it right in the middle of my fellowship. So I used Mapbox, and I had to write directions of how to basically do it. The whole like coding and creating the pop-ups for the map is creating the map is easy, but creating those pop-ups is like just a bunch of code that you have to write. And luckily they can just update the data set that I created and add projects. There's also, I was trying to create a more complicated map where like you could click on upcoming projects and it would only highlight those, or like past projects. But I like got help from someone from Roaring Fork Outdoor Volunteers, because they have a same map, and it's just like the code that she sent me was so complicated, and I was like, I don't have time to like learn how to do all of this. So if there's like the next fellow wants to try and do that, then they can. But it's nice, like the map can stay on there in that simple form. Yeah, and it's free too, which is nice. Yeah.
Let's thank Addie.
Yeah, thanks.
Awesome. Hi, my name is Brenan Bloyd, and I am the Cold Harbor Institute's Water Resource Fellow, and I'll be presenting my project, Wetland Restoration on the Cold Harbor Ranch. To get started, I want to give you guys a roadmap of what I'll be covering in my presentation today. I first will get started with an overview of what the Cold Harbor Institute is and how my project objectives and goals fit within their vision and mission. Next, I'll touch on the site investigation I touched on. I investigated this summer for my project, along with how I developed the restoration designs in collaboration with our committee members. I'll touch on the compliance associated with actually implementing the project, and next, the next steps associated with the project as well. So the Cold Harbor Institute is a local nonprofit that aims to be a learning laboratory for regenerative living practices that bring health to not only our lands, but also our communities. And we do this through our education curriculum for both our community members and youth, trying to create a more positive interaction with our landscape. We also are the Colorado Savory Institute Hub, and we aim to facilitate regenerative land management practices throughout the entirety of the Colorado region. The ranch itself is located about 8 miles east of Gunnison and is home to the confluence into Michi Creek. The ranch has really diverse and rich wetland as well as riparian resources on it. Because of this, 243 acres of the ranch are under a wetland reserve program easement with the National Resource Conservation Service. And this really protects the property in perpetuity from being sold and sectioned up and parceled into different properties, as well as protects it from future development within the easement boundaries itself. It also dictates that the management actions we take on the property have to protect and enhance our current wetlands. And this includes between March 15th and July 15th, groups of 3 people, as well as livestock, cannot be out on the property to protect nesting waterfowl during that vulnerable spring season, and is also for the vulnerable spring season for our wetland and riparian habitats. So we have these really great habitats on the property. So why is there a need for restoration? Well, historical land use, the construction of Highway 50, along with Highway 114, 2 historic railroad grades on the property have really disrupted the natural landscape and the hydrology. And while a lot of these wetlands are providing really great ecological services, we want to restore them to more of a natural conditions and improve the habitats that are already there. Catherine Bickley, along with Nick Story, did a tremendous job of cataloging the wetland and water resources on the property and starting to conceptualize what restoration could look like. And Catherine Bickley decided on a multi-tiered approach, and my project specifically deals with phase 1 of the project. And we plan to implement and monitor the project within phase 1 and be able to use this information to implement more effective restoration strategies within phase 2 and phase 3. So the overall project objectives, the first objective really defines how our restoration activities are improving our wetlands. So we want to increase our inundation capacity as well as improve soil moisture to enhance that wetland habitat and soil moisture. Our second objective really serves to define who we're doing this habitat for. These wetland habitats that are being utilized by wildlife, we want to enhance them, improve them, and improve their opportunities to utilize them as well. The third goal really speaks to Cold Harbor Institute's goal and vision to balance our land management practices with ecological restoration. And we really want to be a model to showcase that grazing along with agriculture doesn't have to be mutually exclusive to restoration. And the fact that these two are actually beneficial for each other and can promote each other. I couldn't have done this project without our restoration. I couldn't have done this project without our restoration committee. Dan Olson with the NRCS was really a tremendous resource in navigating the complexities of the Wetland Reserve Program easement and the compliance associated with actually implementing the project. Brandon Miller with the U.S. Fish and Wildlife provided a lot of technical expertise because he works with other landowners in the area and really provided restoration designs that balance our land use goals along with the restoration of our wetland and riparian habitats. Nate Seward with Colorado Parks and Wildlife, along with Jesse Krutrout with Trout Unlimited, also provided their technical expertise to develop restoration designs that improved and really enhancing for our wildlife habitat that we're utilizing these. So over the summer, I investigated the site. I was out there about once or twice. Over the summer, I investigated the site. I was about there about once or twice a week, and I would take flow measurements of the property to understand when we're getting water, how much water we're getting, and where that water is being inundated and saturating. I really wanted to understand how it was affecting our landscape, how the vegetation was responding, and seeing how the property was changing from the transition from spring to summer and summer to fall as well. I found a baby deer on one of my field days, and on another day I brought out my friend Destin, and we were wading through the water, and we eventually got chased out by some beavers. On our way back, we got a little lost, and so we had to bushwhack our way through some willows and ravaged by mosquitoes. But he obviously enjoyed that investigation enough. He's going to continue the project in the summer. Another part of my site investigation was taking drone images of notable wetland features of the property, specifically within phase 1. On the left, we have the northern oxbow, and on the right, we have the southern oxbow. And an oxbow is a U-shaped water feature that forms based on the meandering of a stream, and eventually it becomes more of a stagnant lake-type feature. But depending on the phase of the oxbow's creation, it still can be internally connected to Tamichi, as you see the difference between the two. But this creates really vital and useful wetland habitat. Swale features, this is also within phase 1, are depression-like features within the landscape. And you can see more of a darker imagery as well as more green, and it's able to hold water, and you see a different type of vegetation composition in there because it creates this seasonal shallow water wetland habitat. So looking at phase 1 from an aerial perspective as well, we see those 2 historic railroad grades along with the irrigation ditch that moves along that north side of the railroad grade and really provides the most of the saturation capacity for that swale. That railroad grade also kind of separates that swale feature from the north and south pasture, from the north and south section. Surrounding the 2 oxbow features that we have these swale features. The oxbows are able to retain water throughout the year and provide that wetland habitat. However, those adjacent swale features are only inundated during that spring and early summer season, just depending on the water availability as well. So what are we doing to improve the property? Immediately at the start of that irrigation ditch along the North Railroad grade, we have a really dense patch of willows, and a lot of that debris in there is diverting our water south into Michi. So we want to clear out those willows, clear out the debris, prune out those willows, and allow our full water right to move across that north side of the pasture. Along that irrigation ditch, we want to install 10 beaver dam analogs, and these structures are intended to slow down and spread out that water. And we really want to inundate that swale that I outlined earlier. In conjunction with the installation of these beaver dam analogs, we want to partially fill a portion of that irrigation ditch that runs north to south with sod plugs. And this is due in part to create a more natural mosaic and improve the sheet flow of the area. And in doing this, we'll also be able to see the full inundation capacity of that swale with the installation of those beaver dam structures. The restoration committee concluded that no restoration actions were necessarily needed at the time for the northern oxbow, just because of current beaver dam activity in the area. However, we'll continue to monitor this component of the project as it continues to progress as well. As we move south into Tamichi, we plan to install a postless BDA structure at the outlet of the oxbow. And we just want to improve the saturation of not only that oxbow, but the surrounding swale features to really enhance that wetland habitat. Outlined in green, we have a really dense, almost monoculture of cattails, and we want to set back their succession a little bit with some excavation. And this is going to open up that area for more diverse vegetation and improve waterfowl foraging opportunities. Because beaver dam analogs are used so prevalently within this phase of the project, I wanted to outline their importance. On the picture on the right, that's actually kind of an unmaintained beaver dam structure within the irrigation ditch. So some of these structures will actually build on top of already existing beaver dams. And as you can see, the water is really saturating and pooling up behind that structure. And over time, it's really going to change the vegetation composition, improve that soil moisture, and help with the recharge and maintain the water table later into the summer season. And how we install these, we pound posts in the ground, we kind of weave willows in between them, put mud and rocks in there. And that's going to allow some water to back up and slow down, but where it's also going to keep it going. It's going to protect against erosion a little bit too. So initially, we kind of thought this project, we'd be working with NRCS, have to sign a few papers, do some monitoring, and we'd be able to implement. That wasn't necessarily the case, and we had to go through a more complicated compliance process. The Wetland Reserve Plan of Operations is a document that outlines the water resources on the property, how how the management of the ranch itself is actually improving and enhancing them, and the overall goals and objectives of the ranch itself, as well as the wetland and riparian resources within it. So we had to add a little section that specifically outlined the restoration activities that we're doing specifically within phase 1. The primary document that I worked on for the approval of this project was the compatible use authorization. And this document really outlines the implementation schedule, the design of these structures, and how they're actually going to be impacting the habitats that they're installed in. We also had to do habitat assessments of the in the areas that we're conducting these restoration activities, along with outlining the expected outcomes from differences in vegetation composition that we're expecting, changes in seasonal saturation, along with changes in total water volume. So the next steps of the project, as I mentioned before, Destin Gerhard will be taking over the project and implementing it this summer. Savannah Adkins will touch on the monitoring component associated with this project and how we're actually defining success in the adaptive management that we're taking to continue to improve and enhance these wetland habitats through our restoration activities. We have a grant through the Upper Gunnison River Water Conservation District to analyze this section of Tamichi on the property. And we want to develop conceptual restoration designs as a result of this grant to really address some of the concerns we have on the property, specifically erosion and threats to infrastructure, and possibly see how our river restoration can combine with our wetland and riparian restoration efforts. And we plan to use all of this information to inform the future phases and be able to develop more effective restoration designs for the rest of the property. So my deliverables to Cold Harbor, I really outlined the process and the people that I worked with in order to develop these restoration designs, understand the property, along with the processes, the compliance associated with navigating the WRP easement of the property and how getting compliance and actually approval of the project works within it. I'm working closely with Destin as soon as he's taking over the project to ensure he's able to hit the ground running and be able to implement the project this coming summer. Our overall goal for the project, we want to be a model not only for the Gunnison Valley, but also all other cold weather, high altitude climates in the world to showcase that sustainable agriculture as well as ecosystem restoration can really coexist and benefit each other. And with that, I have so many people to acknowledge the entire Cold Harbor team, MJ, Lily, Hannah, my project partner, Savannah, Micah for helping me out with everything and anything, responding to all my emails, Butch Clark for providing the funding for the project, as well as Brandon Miller, Dan Olson, Nate Seward, Jesse Kruchow, the restoration committees, helping me out, helping me understand the project, the restoration potential of it. Jeff Sladewski, my boss at the gym, for letting me go out on the property and understand it, as well as Dave Ellerbrook, my previous mentor, helping me with professional advice. Also my family members for supporting me through this whole thing as well. And with that, I'll open it up for questions. Nick.
On the eastern side of the property, there is that high ground, right?
Yes, like above the North Railroad grade?
Yes. The high ground is quite a lot higher than everything else. So there's an irrigation basin and there's another irrigation basin. And then on the other side of the road, there is an area.
Oh, okay. I know.
Do you think it would be possible to use that plug idea to migrate water from the other side of the road into that higher irrigation ditch? So you combat those invasive thistles there?
I might defer this question to Lily Richards, but a part of Catherine's original plan, we wanted to address and kind of create some swale and contour features within the North Pasture, because like you said, we have, I think, 3 culverts that run under Highway 50 and that water right. A part of my site investigation and collaboration with the Restoration Committee, we decided no restoration activities at the time are currently needed, just because the current contours of the landscape were actually adequate to support the little water that we were getting. But as we talked with Lily, the future management of the property, we want to be able to better manage that ditch and be able to really access that full water right. So right now, that just wasn't a priority of the project. But in the future phases, yes, potentially, I think that could be a great idea of addressing those invasive species, trying to extend the wetland and riparian habitat up into that more of that north pasture. Thank you. Hannah.
Great job, Brenan. I had so much fun listening, and so did Murphy. I was wondering if you could talk about like community engagement, how you plan to engage, or how Destin and future fellows could engage the community members in this really cool thing that's happening out at the ranch, beyond like the agencies, obviously.
Awesome. Hannah's question was how can we get more community engagement involved within this project? And notably that was one of kind of the shortcomings of my project, is not being able to engage. We did one volunteer day, and we're able to bring amigos as well as some other students out there on the project. However, I think the future outlook, and Savannah will touch on the field school that could potentially happen on Cold Harbor. But I think just getting people out there, getting people involved within the restoration, the actual implementation, it's going to be very heavily volunteer based, along with a lot of this LTPBR restoration techniques. And then as we continue to progress with the project, I think we can engage with our neighboring landowners and other landowners in the area to really showcase like wetland restoration along with land use, sustainable agriculture can coexist. So that I think that's the long-term goal of how community engagement can really be integrated within this project. Thank you for the question.
Great. Thank you, Addie and Brenan, for covering those aspects of restoration. Now let's dive into some implementation of that restoration. My name is Payten Maness, and I worked with the Gunnison Field Office Bureau of Land Management to implement Bill Zedike's low-tech process-based restoration to improve Gunnison sage-grouse brood-rearing habitat. Before we get too far into it, let me give y'all some initial background. As we've touched on, the Gunnison sage-grouse is a federally threatened bird species here in the Valley. I am happy to report, as of the 2022 let counts, their population is estimated to be up around 3,800 individuals, which is an increase of around 750 individuals from the 2021 let counts. And it has been identified that protecting their brood-rearing habitat of wet meadows is absolutely vital for maintaining those population numbers. This is an example of a wet meadow. You can see that distinct line where it becomes too wet for the sagebrush. They come in different shapes and sizes and have varying amounts of water, but what they have in common is this rich layer of organic hydric soil that acts as a sponge and really makes these areas so vital. They also tend to have a higher abundance of forbs and sedges, which is what makes them important for the sagebrush chicks. They'll come down into these meadow pockets to feed and hopefully gain enough weight to survive the winters here. Unfortunately, historical land uses such as farming, mining, roadway development, and cattle trailing have caused erosion and the de-wetting of these areas, which are just causing us to lose these areas in general. Here in the Gunnison Valley, we mainly use Bill Zedike's low-tech process-based restoration techniques. Bill Zedike is a New Mexico restoration practitioner who has adapted ancestral Puebloan irrigation techniques as a low-tech, low-cost restoration practice. It is low cost thanks to the use of native materials like rocks and sticks, and it's low tech because the majority of these structures are built by hand and really depend on you getting down on the ground and seeing how the water will interact with your structures. So now that we have some initial background, let's get into it. My field season ran from May through September here in the Gunnison Valley, and in that time, I was able to add 73 new structures, restoring 24 meadow acres, as well as maintaining 35 structures at sites including Sapanero Mesa, Monson Gulch, and Signal Peak. My main project site was Upper Willow Creek, which is a dry, ephemeral wet meadow system. The majority of the water at this site comes in the form of snowmelt. The site sits at the upper portion of the Upper Willow Creek drainage, and due to the lack of water, as well as a very low sediment supply caused by being at the top of the of the drainage, it has extremely low restoration potential. In order to restore erosive features, you need to abrade to build up sediment. Due to this low restoration potential, the site goals were to preserve the existing meadow as well as to slow down any water that is passing through the site. This site has been surveyed and permitted in previous years, like Brenan touched on a bit, but this site, we started off with a final walkthrough to really cement what features, what structures we are going to be putting in, specifically because we did have a couple head cuts that were extremely challenging simply due to their size. We had about 3 or 4 head cuts that were 10 to 18 feet wide, and some of them were 4 feet deep. But they also had these partially healed sides, which created a dilemma where we didn't want to remove more soil than necessary for restoration. Because of this, we did opt to create some hybrid features where we combine 2 structure types. This is fairly common within low-tech restoration. At this site, we mainly utilized log and fabric structures as well as rock layback structures. Log and fabric structures are by far the most intensive complex structures we build, but they are incredibly good at filling in large head cuts. To build them, you first have to start by squaring off the back of the head cut so the logs sit flat, and then you lay down a filter fabric and pound in posts at 4 corners, and then lay down and wire in all of your logs to each other so that you're not accidentally creating a raft that's going to float away on the first rain. You also need to make sure you are adding some rock armoring on the sides and at the bottom so that you're not creating any erosive features when you're implementing these structures. The rock laybacks are a lot simpler to build. You simply take a hand tool and you smooth out your head cut, and then working with the larger rocks at the bottom to smaller, smoother rocks at top, you kind of Tetris them together so that when the rain does come and the water comes through, they're not going to blow apart on you. And Sean Connor, our contractor, really wanted us to emphasize that the goal of these structures is to strive for beauty and inspiration. So once we had decided what structures to implement, we were able to take measurements for how many supplies we would need. This included myself and Max Sawyer sawing 150 4-inch logs by hand and hauling them, as well as several tons of rocks out to the site. Being able to stage before we actually implement restoration is incredibly important. We typically only have a handful of days where we have crews and volunteers out to implement these structures. And while we did have over 1,000 hours of labor to implement our structures, we got pretty close to not being able to implement all of them. And to implement our structures, we mainly work with 2 different groups, volunteers that come through us from organizations like Backcountry Hunters and Anglers, Western Colorado University, and of course, HICA. These volunteers come to us with little to no restoration experience. So our days with them are typically more focused on education because we do want to create volunteers that can build beautiful functional structures, but also it's very important that we continue our community buy-in for this work. The other group we typically work with are crews, mainly WCCC, Western Colorado Conservation Corps, who is an essential partner to many environmental projects on the West Slope. Unfortunately, they can be a little complicated for us to work with. Their field season typically runs from June through November, with the majority of their crew members ending their contracts in September or August due to them returning to school. We typically don't implement restoration until September or August. So by the time we get the crew members, they are extremely fatigued from long field seasons, as well as coming to us with very worn down, broken gear and reduced crew sizes. The first WCCC crew we had was absolutely wonderful for us. We ended up having to change our plans very last minute and had them at a different restoration site nearly every day, which just added a lot to their camping logistics. And the second WCCC crew we had was supposed to be 2 crews in 1. We were planning on using them to finish up all of our structures at Upper Willow Creek. Due to it being the end of the season, we weren't exactly sure how many crew members we would get until they showed up the morning of. But we had hoped for around 24. Unfortunately, as you can see, we got about 11. The silver lining in that is we did have a couple crew members from our first WCCC crew, so they already knew what was going on and how to build our structures, which was incredibly helpful. And honestly, that was some of the biggest challenges I faced this summer. Is nearly every single plan we had was kind of turned on its head. And while this was a great learning opportunity, it was really challenging. For example, we had planned on having our first WCCC crew at Monson Gulch. Monson Gulch was restored by MEM graduate Max Sawyer in 2022. And while we had a lot of stuff we wanted to do at that site, we were informed of a water right complaint. And instead of bringing any crew members there, we ended up meeting with the water commissioners several times, who instructed us to notch all of our structures on the site to keep the water flowing through as quickly as possible, as well as asking us to install 4 partial flumes so that we could measure the water loss throughout the site. We also ended up losing a bit of crew time with our second WCCC crew. We had a partner in the valley that was putting on a large volunteer event who had a miscommunication with the contractor delivering rocks. And while it is absolutely vital that partners be able to pivot and help each other to make this work possible, it did kind of put into question if we'd be able to finish all of our planned structures at Upper Willow Creek. Luckily, another partner in HICA really came through for us and added an extra volunteer day, as well as just bringing out an amazing volunteer group on Public Lands Day. And we were actually able to implement all of our plant structures. And while I do have so many awesome stories I'd love to share with y'all, I am gonna end it thanking a bunch of our sponsors and partners, especially Andrew Breibart, who was with the BLM as my community sponsor, MJ Pickett, who was my faculty advisor, Cheryl Schwellick from the Upper Gunnison River Water Conservancy District, Max Sawyer, who is an MEM graduate and BLM technician, and Sean Connor, who was a biologic contractor, all who taught me so much this summer, as well as all of our wonderful volunteers and crew members without whom we really couldn't have done any of this work. Thank you.
Questions, anyone?
Did the structures that you had to notch because of water right complaints, are they still functioning in some way, or you're gonna see after the measurements whether they're helping or not?
The site is incredibly flashy site. It gets lots of high water when it rains. So when it does experience heavy rainstorms, the structures will partially function. Honestly, one of the challenges with notching the sites with the structures is that we did have a lot of sediment build up behind our structures. So we had to be very careful when we went in and notched them that we weren't going to be accidentally dumping a bunch of sediment into the water right holders ponds. So, yeah.
Okay, let's give Payten another hand.
Hello, my name is Savannah Adkins, and I am the Cold Harbor Institute Research Coordinator Fellow. And today I'm going to be talking about my project where I developed an adaptive wetland monitoring protocol for the Cold Harbor Ranch. So here's just a roadmap of what I'm going to be touching on during the presentation today. Why Cold Harbor should care about monitoring and wetland restoration efforts, the role that water plays on the Cold Harbor property. I'm going to touch on the monitoring protocol and the different components that went into it. The expected outcomes after restoration and monitoring has begun. And then I'm going to shift gears towards the end of the presentation and talk about the field school that will continue wetland restoration efforts on Cold Harbor's property and within the Gunnison Basin. Okay. So why should Cold Harbor care about monitoring and wetland restoration? So as Brenan pointed out in his project or in his presentation, Cold Harbor has a wetland reserve program WRP easement on 243 acres of its property. What this does is allows private and tribal landowners to protect, restore, and enhance wetlands degraded by agricultural uses. So Cold Harbor has made a commitment to protect, restore, and enhance its historical floodplains through this WRP easement. Monitoring is important to help identify indicators of project success and performance standards, and without it, it would be hard to determine the impacts of the physical environment, and it's best to ensure restoration efforts are sustainable. So Cold Harbor falls under that red star right there on that map. We are part of the Upper Gunnison River watershed, and we have one major stream that flows right through the middle of the property, and that's Tamichi Creek. Tamichi Creek is a 71.8 mile long tributary to the Gunnison River, and the Gunnison River is one of the largest tributaries to the Colorado River. So that just kind of gives us an overview of how important restoration work on Cold Harbor does and affects downstream people as well. Can you go back one? Tamichi Creek flows for 2.5 miles on the Cold Harbor property, and itself has 4 major tributaries. One of those tributaries can also be seen on the Cold Harbor property, and that is Cochetope Creek. So here is a map outlining the different phases that Brenan discussed in his presentation. I just kind of wanted to orient everyone and highlight the diversity of wetland and riparian types seen across the Cold Harbor property. Here you can see about 6 different wetland and riparian types found within the Cold Harbor boundaries, and all 6 of these types can be found in phase 1 alone. So here's another map outlining the main features found in phase 1, just so we're all oriented as to what we're doing for monitoring and restoration efforts in phase 1. The majority of efforts are going to be in that north pasture along the historic railroad grade and irrigation ditch, also within that north swale feature. A lot of monitoring points of collection will also be done in that southern oxbow just below Tamichi Creek. And then here we can see exactly where Cochetope Creek flows into Tamichi Creek within the property. So the monitoring protocol has 4 components of measurement on it. It analyzes soil moisture, vegetation conditions, water quality, and a presence of wildlife. There are 20 probe locations that will be within phase 1. The probes will be used to collect samples that will assess the overall health of the wetland, the status of the water table, and the nutrients found within the landscape. Here you can see exactly where those soil moisture probes will be placed, following the extent of that north swale feature, also along the historic railroad grade, and then just below Tamichi Creek, and you can see there are a few more probes within that southern oxbow. So there are 6 line transects dedicated to phase 1. There are 12 collection points that are along those line transects where a monitoring structure will be placed to track the changes in vegetation. With more than 25 species of aquatic plants, grasses, and horsetails found on the Cold Harbor property, it's important to track these changes and assess the impacts of vegetation after restoration work. So here is a picture of the monitoring protocol that will be placed at each collection point along those line transects that myself and a fellow MEM student built last summer. This design is modeled after this one from the Savory Institute, the Cold Harbor and Savory Institute partner, because they share the vision of informing the best living practices through holistic management. And this method allows private landowners to practice effective and sustainable restorative methods independently without relying on a third-party system coming onto their property and potentially creating something that they can't manage on their own. Another component of the monitoring protocol is water quality. Assessing water quality before and after restoration work can inform how the project has affected the land's hydrology. We use practices and equipment provided by Riverwatch. Riverwatch is a volunteer-based water quality monitoring program that measures watershed health all across the state of Colorado and has partnered with Colorado Parks and Wildlife to do so. We have 2 points of sample locations on the property. One is just below phase 1 on the east end of the property, just before Cochitope Creek connects with Tamichi Creek. And another one is in phase 3 of the property along Tamichi Creek on the west end. Here are just a few photographs of myself and undergraduate Jocelyn Karochi, who assisted me in collecting the samples out on the property. This is just some photos showing how we took all the equipment and tools out to the collection site. We did some assessments measuring pH, alkalinity, dissolved oxygen, and hardness. And then the final component of the monitoring protocol assesses the presence of wildlife. So there are 9 recommended locations where wildlife cameras will be installed, and this will allow us to identify different species and how they respond to restoration and measure habitat diversity and wildlife activity. The most ideal location currently on phase 1 is to place these cameras along that historic railroad grade because posts are already present on the landscape. However, to grasp the full extent of the phase 1 and project site, other recommendations have been, or locations have been recommended. Here are just a few cute photos of the animals found on Cold Harbor's property. We see mule deer, elk, foxes, and bobcats, but we also have other wildlife like badgers, bears, and different local and migratory birds as well, birds. So here's a list of the outcomes that we expect to see once restoration is completed and monitoring is able to start. That is a higher water table, an extended above ground water reach, and increased sediment retention, improved water quality, restored historic hydrologic functions, greater in-stream habitat diversity, and improved access to water resources for riparian and wetland vegetation. So what else is Cold Harbor doing to promote restoration and monitoring efforts? I'm so glad you all asked. Here is when I'm going to shift gears a little bit and talk about the low-tech process-based restoration primer and practicum that helped inform the methods used in the monitoring protocol. So last September, Dr. Michael Russell created the LT-PBR primer and practicum for his wetland restoration and conservation course. After meeting with several stakeholders to discuss the idea of a summer field school of trained applicants in wetland restoration. As the teaching assistant, I helped to facilitate the logistical tasks both in the classroom and during the field days. This was really great because it allowed students to work with industry professionals and gain hands-on experience in restoration work. The photos on the left show students installing beaver dam analogs with Trout Unlimited on a private ranch. And the photographs on the right show students working with the Bureau of Land Management in Upper Willow Creek installing 1 rock dam features. So because this project was such a success, it kind of led to the question of how can we continue to offer an educational opportunity for students to gain hands-on restoration experience. So the conversation of offering a summer field school grew, and because of the wetland restoration plans and potential on the Cold Harbor Ranch, both Western and Cold Harbor continue to shape the idea of a summer field school. Through the collaboration with stakeholders like the Upper Gunnison River Watershed Conservancy District, the field school can help create the next generation of industry professionals dedicated to restoring critical wetland and riparian ecosystems. So in conclusion, this monitoring protocol guides the next steps of what restoration efforts can do for Cold Harbor and the Gunnison Basin. Both the monitoring protocol and the summer field school are valuable resources that can be applied to future projects and shares the benefits of wetland restoration with community members. So I would like to thank all of those who supported me during the year of this project, Dr. Micah Russell and my mentor, Sally Thode from Western Colorado University, Cheryl Swellage with Upper Gunnison River Water Conservancy District, and everyone at Cold Harbor, Hannah Schaefer-Tibbett, Lily Richards, my project partner, Brenan Bloyd, community sponsor, MJ Pickett, and Bitch Clark, all of which could not have been successful without. Thank you.
Questions?
Yes.
Do you can contact the U.S. Geological Survey? They also did water monitoring out there, particularly after there were major truck tipping over in the Cochetope stream on the highway. Different chemicals would get involved.
No, I did not know that that had been done in the past, but we definitely have a good inventory of past projects that I'm sure next fellow Justin Gerard will be able to take over.
Other questions?
Leah?
What would be like the timeline of implementing this field school?
Yeah, that's a great question. Leah asked what would the timeline be to implement the field school. So the conversation began really this year, so it's really in its early stages. The hope was that it would begin next summer, but with kind of what had happened during the school year and the logistics of getting the stakeholders together, it looks like it might happen in the next few years, but hopefully, in the next few years and pretty soon.
All right. I know there are folks who have additional questions. We will circle back and give you an opportunity at the end.
Hi, everyone. My name is Yetunde Rotimi, and I'm a Master of Science in Ecology candidate. My thesis is based on post-restoration monitoring of wetlands in the Gunnison Basin. And precisely, I have worked on soil moisture monitoring on a restored wetland using field-based and remotely sensed data. So what's the need for monitoring restored wetlands? Just as Savannah already mentioned in our presentation, post-restoration monitoring is very essential for determining the sources of restoration activities. So after restoration activities were carried out in the Gunnison Basin, restoration managers came up with certain objectives. And one of these objectives was to engage in a continual monitoring of restored wetland. This was to be sure if the restoration activities that have been carried out were successful or not. And some of these monitoring activities include vegetation monitoring and soil moisture monitoring. So what is the relevance of using remotely sensed data? Researchers have been able to discover the effectiveness of using remotely sensed data in monitoring. And most of these researchers have used remotely sensed data in monitoring vegetation productivity, soil moisture monitoring, among others. Also, there are limitations with traditional techniques for soil moisture monitoring. And what are some of these limitations? These include cost, spatial resolution, time-consuming approach, and associated destructive mechanisms. Therefore, for this study, we identified 3 objectives, and the first one was to determine the accuracy and the potential of satellite images in estimating soil moisture. Also, we wanted to understand the potential and accuracy of Black Swift E2 unmanned area system in estimating soil moisture. And finally, we wanted to understand the potential of these 2 remotely sensed sources in estimating soil moisture content beyond the soil surface level. Our study site was Sapinero Mesa Watershed, which is originally owned by BLM. Restoration began on this site in the year 2017. However, nothing was done regarding soil moisture monitoring till the year 2019. And when soil moisture monitoring eventually started, the use of installed loggers and sensors were employed. These installed loggers and sensors, just as I've mentioned earlier on, they are quite limited. So therefore, we are looking at the place of remotely sensed data in bridging this gap. The map of our study site is represented here, as we can see. Our sampling design was systematic sampling. Across our study site, we delineated a 0.5 square kilometer sampling area. And this was where we collected our field data and remotely sensed data. Also, we worked with a spatial resolution of 30 meters. We randomly generated 5 transits within our study area, and across each transit, we established 10 sampling points. Altogether, we worked with a total of 50 sampling points for our field data collection. First field data collection was carried out on the 1st and 2nd of August. From 48 points, we collected soil samples at the depth of 0 to 20 centimeters. And at the depth of 0 to 10 centimeters, we collected soil samples from 50 points. We were not able to collect soil samples from the entire 50 points at the depth of 0 to 20 centimeters because of the rocky nature of some of those sampling points. Our second field data collection was carried out on September 9. Out of the originally established 50 points, we only worked with 30, and those are the 30 represented with the yellow markers there. This was as a result of adverse weather condition. We couldn't work with the entire 50 established sampling points. Therefore, at the depth of 0 to 10 centimeters and 0 to 5 centimeters, we collected soil samples. After the collection of our soil samples, we took them to the lab, we processed them, kept them in the oven for 3 days at a temperature of 105 degrees Celsius, and afterward, we calculated our gravimetric soil moisture. We work with 3 basic remote sensing data sources, and those are what are represented here. We work with the Black Swift E2 unmanned area system. This was supplied by the Black Swift technology. They are located here in Colorado. We also work with Landsat 9, and finally, we work with Sentinel-1A synthetic aperture radar. And these are the specifications of the various remote sensing sources we work with. From our remote sensing sources, we analyzed indices. From Landsat 9, we analyzed 2 major indices, which are represented here, NSDSI2 and NDVI. From our Sentinel-1A, we analyzed the backscattering coefficient. Then we also analyzed 6 vegetation indices from our Black Swift E2 unmanned area system. And we also got our thermal data from the E2. Data analysis were carried out using these different softwares. We used Snap, Sentinel application software. We used the ArcGIS Pro. We used the Solvi software. Then our statistical analysis was carried out using the R programming software. This is just a flow chart representing the various analyses that were carried out. Precisely for our soil moisture modeling, we work with linear regression model, whereby our remotely sensed data were used as predictor variables to predict our soil moisture data. Afterwards, we carried out our diagnostic assumption tests. Then we validated our models using the K-fold cross validation, whereby your data sets are subdivided into subsets. Then this subset will be used to test or to test the performance of established models. The regression results between the best fit indices and soil moisture data showed that satellite indices were able to predict soil moisture very well at the depth of 0 to 20 centimeters. However, out of the 3 satellite indices we work with, the normalized difference vegetation index worked best at that depth with an R-square value of 0.73. Out of all satellite indices we work with, NSDSI2 was able to predict soil moisture best at the depth of 0 to 10 centimeters and 0 to 5 centimeters. The best prediction of soil moisture was at the depth of 0 to 5 centimeters by a UAS-based vegetation index, otherwise known as normalized difference red edge index, NDREI, as we can see. Based on the lowest MAE, that is the mean absolute error, and RMSE, root mean square error. Results show that the best model is at the depth of 0 to 20 centimeters, the one in bold, yeah. That was our best model that we got, based on the lowest RMSE and MAE. To test the performance of the best model, we used it to predict soil moisture content at all other depths. And we had high correlation values between predicted and observed soil moisture. Those are the Pearson correlation values represented there. For the model validation results, we had to validate, just as I stated earlier on, we used the K-fold model validation, and we validated the best model that we said we had. and found that it was still like it remained the best model even after validation using the K-fold cross validation method. Conclusion, our findings support our hypothesis that satellite and UAS data, they are effective in estimating soil moisture. Also, we're able to understand that these remotely sensed data are quite effective in estimating soil moisture, even at the deep soil level, like that is beyond the soil surface level. They were also able to predict soil moisture accurately. The ability of remotely sensed data in predicting soil moisture was most accurate at the shallow soil level, that is at the depth of 0 to 5 centimeters. And generally, the most accurate predictions were from UAS-based vegetation indices, which were obtained from our 5 multispectral bands. And we attributed this to the final spatial resolution of UAS images. What do we want to do next? Now we are going to be further validating our best fitted model by getting new in-situ data from across our study sites. Afterwards, we are going to be using this best fitted model to generate a soil moisture time series. This will give us an insight into understanding if there had been an increase in soil moisture content since restoration began. And finally, we would like to understand the application of our established model on all other restored sites in the Gunnison Basin. This study was supported by these various funding bodies, the Bureau of Land Management, the Nature Conservancy, Colorado Parks and Wildlife, and UGW. So, yeah, it couldn't have been possible without these funding bodies. And most importantly, I would like to appreciate God for all he has been to me all through my stay here at Western. I would also like to acknowledge my academic advisor in person of Dr. Jenny DeMarco, even though she had not been here, but she has always been coming through. Then I would like to appreciate my committee members. They've always been forthcoming also. And I would like to appreciate family and friends and all you people who took the time to attend my presentation. Thank you so much.
Couple of questions.
I guess I was curious. So you found out all of this research and you have the data. What can someone like the BLM or even like a land manager then do with the data? Like what will it inform and what will it influence in like land management decisions?
Yeah, so you're asking what is the essence of this, right?
Yeah, essentially like now that you have all this excellent data that you spent so long collecting and understanding, how can it, best inform land management decisions?
Yeah, so the most important aspect out of all of this is we getting to know that remotely sensed data are quite effective in predicting soil moisture content on restored wetlands. People have been carrying out various research work on agricultural farmland, on all other different ecosystems, but nothing precisely, not many research work have been carried out on the restored wetland using remotely sensed data. Now that we know that this is effective for predicting soil moisture content on our restored sites, we are going to further be looking into its applicability on all other restored sites here in the Gunnison Basin using the model that we've established. So if it ends up working, then that makes perfect sense. Okay.
Did you find any anomalies in your imagery that you couldn't quite explain?
Not really. However, this is not all to my research. This isn't everything about it, because in addition to gravimetric soil moisture, we also collected volumetric soil moisture from the field using TDR probes. However, we found that the results were poor for volumetric soil moisture compared to gravimetric soil moisture. We wouldn't know why. We understand that we didn't calibrate our TDR probes before going to the field. So we feel like that could be one of the problems or anything. Yeah.
Well done. Impressive, right? Incredible work all around. And now we have an opportunity to direct questions to any of these individuals or the panel as a whole. So who would like to start us off? Matthew.
This question is for, I guess, Brenan and Savannah. So I'm curious about the culverts where the water can flow off the hill under the road onto the ranch really dictate how the water gets onto the ranch and where the ranch will be inundated. In your experience, did you find out that there's any chance that that could be changed in the future and there would be new and more expanded ways for water to infiltrate the ranch coming off the hill?
So are you asking if our management activities can change where and when and how we're getting water on the ranch?
I guess more like, is it possible? I mean, partially that, and also, is it even possible like that you can basically make some more holes under the road to infiltrate in a more even way? Because it seems like, well, we've anthropogenically wetted the ranch based on where those culverts were created. So is there a path forward to like poke more holes under the road?
So yeah, he was asking if there's a way we can change it, if there's a way we can kind of alter it and possibly install new culverts under the road to better manage it and better access our water right. I think anything's possible. Again, I defer to Lily Richards on the exact specifics of that. But like I said, the plan going forward is to better manage that ditch that's north of the Highway 50, and then we want to realign the one in the corner there. So we're in the process of seeing what our options are in better accessing that water right.
Thank you. Other questions?
I'm curious whether whether you have beavers adopting your BDAs once you put them in. How do they react to the changes to their environment?
Great question.
Yeah. The question was, do beavers eventually adopt the beaver dam analog structures? And I think there's opportunities for them to, but not specifically at the Cold Harbor. We haven't had it installed any BDAs yet, so specifically there, not necessarily.
Taylor Park has done some BDA work, and they have had beavers that have come in and taken over and expanded the BDAs they have put into place. And they have some beautiful pictures of beavers hanging out on the BDAs.
Yeah. I was just gonna say it's the Trail Creek project that I highlighted. There's like the first year they implemented BDAs, a beaver family came to that one, which is really cool and quick too.
Other questions? Ma'am?
My question was for Payten. How much prior knowledge did you have about low-tech restoration methods going into it? Because you seemed really well versed when you were presenting.
Well, thank you for that. The question was how much knowledge I had coming in doing low-tech restoration. I'll be honest, coming into Gunnison Valley, I had none. I had absolutely none. I really was interested in riparian restoration in general, and it wasn't until I came into the Gunnison Valley that I learned about it. And I was very lucky that Max Sawyer was trying to bring out MEM first years for someone to take over his project, and there were a lot of opportunities for me to go get my hands dirty and experience it before I committed to the project. But yeah, basically none coming in.
Let's go here.
I've got a question for Savannah. So with the camera stands with 1 meter or 1 square yard PVC structures below them, I guess I'm just curious, what do you anticipate seeing or finding? What purpose? How will those, inform your assessment?
Yeah, absolutely. So the question was what we expect to see after installing the camera traps to, see how wildlife respond to restoration work. So the idea was, the historic railroad grade has a ton of historic posts already on that grade, kind of where the railroad lined up. And so the idea was that the camera traps can be placed there and kind of gauge whether activity is increased or decreased after restoration work is implemented, to see if migrating waterfowl use the landscape differently, and kind of that idea.
My question is really specific to the ones with the cameras that were facing down on.
Oh, I see. Okay, yeah. So using the monitoring vegetation conditions The camera will be attached to the top of the monitoring structure that I built last summer. The idea is to kind of the same thing, use pictures to gauge the difference in vegetation to see if invasive species are using the water to their advantage or if native species are using it to their advantage, to see if it's retaining water or if it's not retaining water, just kind of gauging visually exactly what's going on with vegetation.
Like a time lapse.
Yeah.
Great questions, thank you. Anna, did you have another one?
If there's someone else, that's okay.
Please, we have
Okay.
time.
Okay, I guess I was just curious. Well, first I should say, you all did an excellent job and I had so much fun learning about the projects that I didn't know much about and seeing our fellows do such a great job too. But the question I should get to is, I guess in this process of your project, was there something that either like surprised you or, yeah, I guess surprise is the best word, in your learning or in some type of result you're given or just, yeah.
Well, I wouldn't. Yeah, like, was there anything that was surprising, right?
Yeah.
Okay. Was there anything that was surprising during the course of like carrying out this project? That's what you want to know.
For everyone's projects,
For
yeah.
everyone. Well, just as I explained earlier on, if there was only one thing that was surprising, it was the fact that our volumetric submeasure didn't actually provide the result that we're looking forward to. And we're sort of like surprised, like what could be wrong. I think that was just, I didn't really have anything that was.
Yeah, I think the biggest thing that I was surprised by carrying out this project was just how immersed in wetland restoration our community is. It was really interesting coming to the Gunnison Valley. I had no prior knowledge of wetland restoration or wetland ecosystems in general, so it was really incredible coming into the Indian program and just becoming more versed in that, and through the project just becoming more knowledgeable of this incredible ecosystem and how diverse it is and how many different wetland ecosystems there are out in the world. And yeah, that was pretty cool.
My whole project was kind of surprising because everything did change. But it also, it was really cool and surprising how interconnected every single project was. Like I was with the Bureau of Land Management, but we worked with Ugger Wicket a lot. We worked with the Park Service, CPW, with WCCC. We worked with PICA. We worked with everyone in the Valley. And it is really surprising how interconnected everything is. And that's what makes all of this project work so important and so functioning, basically.
Yeah, like everything about my project, like Payten said. But I think the biggest thing for me was understanding the WRP easement is really there to support wetlands and protect the property. However, like getting more and more into the project, there just seems to be more and more red tape to go through and compliance to apply for it. So just understanding that there's so much work that just goes into actually implementing and creating a project like this before even boots get on the ground and the work actually begins, before money even gets involved. Just getting the approval and the proper approval for it that's a really complex process that I was surprised, but I kind of also enjoyed working through.
I would say I came in not knowing anything about low-tech process-based restoration or wetlands or anything like that. My background's in archaeology, so I'm always thinking about the landscape in the past, and it really surprised me of like how I've been looking at water and how it's so different historically, the landscape. I learned tons about beavers, like just they've been pretty much just taken off the landscape and how that really changed our water systems. And then even with wet meadow restoration, that some of the erosion caused in these meadows was, from like wagons, from like people moving across the West. So I think that's just so surprising to me to think how just our water landscape has been impacted historically. It's really interesting.
I love that we have so many converts to wetland restoration. That goes straight to my heart. Brett.
Yeah, I guess I don't know that much about this low-tech wetland restoration efforts. Are there high-tech, non-process based things things like, I guess my question is, if money wasn't an issue, would there be other interventions that you'd be trying to make on the landscape that might better serve your purposes? Or are these low-tech practices that you're using, are they the best practices?
Great question.
Yes and no. A lot of the traditional restoration are really focused on larger systems, especially larger systems that have infrastructure around them. So because they have that infrastructure, they have to be super, super engineered and well managed, because you don't want to take out a road, you don't want to take out someone's house. And due to the smaller size of these systems, they don't need that same intensive restoration that you would do with the bigger systems.
I think it's funny. It's like if money wasn't an issue, because working with the restoration committee, they have these big ideas and like, well, we could do all this and this and this. And one of the ideas that was brought up was like, well, we can reroute to Michi and we can like really re-engage and restart some of these wetland habitats. And while that's a tremendous idea, it's $500,000 project in order to do that. And I think the low tech process base is just a step we're getting in there. But to address some of those larger issues, like Payten said, these are smaller issues that we're addressing. To address those larger issues, yeah, we have to do more conventional restoration techniques.
Great. Anyone else? Yes, Sean.
Yeah. So through all of your projects, you all highlighted these really cool, like very situation unique solutions. And I'm just kind of curious if there's any like principles or techniques that you all plan on taking forward in your lives as you potentially move to places that aren't high sagebrush meadow wetland restoration.
Sorry, that's yeah.
How I interpret the question is what kind of methods are we taking away from to other environments that aren't necessarily so collaborative, so sagebrush and low tech process space? Is that correct?
Yeah. And what insights did you get?
And what insights did we get? I think for me, dealing with a lot of the compliance aspect is like knowing what questions to ask and asking the right questions in order to advance the project. And when you kind of reach a roadblock in the project, still being able to still move laterally, and progress on the project. So understanding where maybe you're waiting on something, but it's understanding how you can still progress and understanding what questions need to be asked and solved.
I think, first of all, I'll definitely take the community engagement with me in my future. I think one of the biggest things I've learned in this program is just how collaborative the Gunnison Valley is. Another thing too is I think I'm going back to archaeology after this. I just got offered an unofficial offer for a job here. So I will really take what I've learned through wetland restoration. It's how I'm looking at the landscape and identifying people in the past and how they would have interacted the area here.
So one thing I didn't really touch on in my presentation is when we're deciding what structures to implement, we do what's called reading the landscape. And that was a really cool technique where literally we'd go out into the sagebrush and find this dark hydric soil and look around and see rushes and go, this used to be a wetland. And that ability to go out and be able to identify that these areas don't look how they would have looked 100, 200 years ago, I think is something that's really important. And if more people understood, maybe we'd have a lot more restoration efforts to be able to do them.
Yeah, kind of going off of what Payten just said, I think reading the landscape is something that I'll take with me and something that I didn't really have before having the project, like being able to go out to the site and understanding that it was a historic wetland and what headcuts are doing to the landscape and how irrigated ditches like need to be expanded and extend that water table. It's just a really cool tool to be able to have that I didn't quite have before. And I think something that I'll take away with me no matter where I go afterward is like collaborative management. This project really allowed me to work with various different stakeholders from the low-tech process-based primer and practicum in the field school, and having those conversations with other people in the community and how excited other people can get and how this is like, such a major topic for the Valley has been really cool. And I think I'll just take collaborative management with me everywhere.
Yeah, for me, beyond wetlands, and as one who is interested in the management of ecosystems generally, I think one thing that would just stick with me is to continue like investigating or making inquiries on how these essential tools can be applied into conservation, management of ecosystems, and even natural resources, basically.
Great. Well done. Congratulations.